Hello students, welcome to Physics Bouquet. In this video, we are going to discuss about time independent Schrodinger equation. It will be derived from time dependent Schrodinger equation. Time independent Schrodinger equation. From time dependent Schrodinger equation, we have I h cut del psi by del t. Here the wave function is a function of x and t, position and time, and it is equal to minus h cut square by 2m second order derivative of wave function with respect to position plus potential energy, which is exclusively a function of x, psi xt. This is time dependent Schrodinger equation. And the wave function is given by a exponential minus I by h cut et minus px. So it is an expression in terms of momentum and energy. Let it be equation number 1. Let it be equation number 2. नहीं, इसको इक्वेशन नंबर 2 नहीं लेते हैं, इसको थोड़ा सिंप्लीफाई करते हैं. सी इट कैन बी रिटन एज ए एक्सपोनेंशियल, इसको ब्रैकेट ओपन कर देने से माइनस आई बाय एच कट ई टी इंटू exponential minus minus becomes plus I by h cut px. Now this A, which is the amplitude, and this exponential I by h cut px, let us put them together. Px into exponential minus I by h cut et. Since this exponential I by h cut px, it is dependent on position and independent of time, we can write it to be psi x exponential minus I by h cut et. So our psi xt is now expressed as product of psi x and exponential of minus I by h cut et. Let it be equation number 2. Now put this equation 2 in equation 1 in place of psi xt, psi xt, psi xt. Let us put the expression in equation 2. Then we will obtain I h cut del by del t of psi x exponential minus I by h cut et is equal to minus h cut square by 2m del square by del x square. In place of psi x t, psi x exponential minus I by h cut et plus Vx psi x exponential minus I by h cut et. Now differentiate it with respect to time. Differentiating with respect to time, we have it is independent of time. It can be put outside and its derivative can be written as minus IE by h cut exponential minus I by h cut et. Taking derivative of this with respect to time, we obtain this. T is multiplied with this, so it gets multiplied here. That is equal to minus h cut square by 2m. Here it is dependent on position, so this is dependent on time. Since we are differentiating with respect to position, it can be taken outside. Minus IET by h cut del square psi x by del x square plus Vx psi x exponential minus IET by h cut. Now you see, in each term there is exponential minus IET by h cut. So divide throughout by exponential minus I by h cut et. Dividing throughout by this, we obtain I h cut psi x to minus IE by h cut is equal to minus h cut square by 2m del square psi x by del x square plus Vx psi x. Now here there is a minus sign, and this I into I square is minus 1. So that this minus and this minus becomes plus, and this h cut cancel out. So we obtain E psi x is equal to minus h cut square by 2m del square psi x by del x square plus Vx psi x. Now put these together and multiply with 2m by h cut square, or bring this side, h cut square by 2m del square psi x by del x square, and in E psi x and V psi x take outside psi x, so we obtain E minus Vx psi x is equal to 0, or after a little bit simplification, multiplying throughout by 2m by h cut square, we get del square psi x by del x square plus 2m by h cut square e minus v x psi x is equal to 0. And this equation is popularly known as one-dimensional time-independent Schrodinger equation. You see here the psi that is involved is dependent on position only. Therefore, it is called time-dependent Schrodinger equation, or it is also called stationary state Schrodinger equation. Stationary state Schrodinger equation. Why it is called stationary state Schrodinger equation? Because here the probability density, actually the probability density, what is probability density? Rho is equal to our psi xt square, and this is nothing but psi xt psi star xt, psi and its complex conjugate. But psi xt is what? A exponential psi x exponential minus iet by h cut. This is psi xt, and its complex conjugate will be psi star x exponential plus psi et by h cut. If we multiply this with this is minus, this is plus, so exponential 0 means 1. So it becomes psi x into psi star x, that means psi x into complex conjugate of psi x. So it becomes psi x mod square. So you see psi xt square, psi xt का मॉडुलस का स्क्वायर is equal to psi x का मॉडुलस का स्क्वायर. Therefore, it is called stationary state equation. So this is about derivation of time independent Schrodinger equation. It completes the derivation. नेक्स्ट वीडियो में एक अलग टॉपिक के साथ मिलेंगे. हैव ए गुड डे.